So we have an example here. An example, an arrow is shot towards a wall 50 meters away from an initial velocity that makes an angle of 45 degrees with the horizontal. It strikes the wall 35 meters above the ground. Assuming that the arrow was released from the ground level, find the initial velocity of the arrow. Okay, so first is we're gonna identify that there is a given. The given are distance of the arrow, no? Okay, so say for example this is the ground, and the arrow, I'm gonna represent the arrow something like this. So kana lang, okay? Something like that. So that's the arrow from the ground, and according to the problem, it makes an angle of 45 degrees with respect to the horizontal, and an arrow is shot towards a wall 50 meters away. No? So 50 meters away. So say for example, this is the wall. Okay. So this arrow is shot from this point here towards here with a distance of 50 meters away from the wall, and it strikes 35 meters above the ground. So this is the ground, and say for example this is 35 meters here from the ground. So this is 35 meters. Okay, so it strikes the wall. So say for example mao na iyahang path of striking. Okay, so itong tarongon. So that's the path of its striking, and after some time abot ng arrow diha, no? So mo na siya na diha ang arrow, and then ang question is what is the value of the initial velocity? Okay, so with this example, we're trying to solve for the velocity, and the condition that we only have is distances 35 and 50. So 35 represents the value of positive y. Why it is positive y? Because the original position or the original point is here, and the final point is here. As you observe, the final point is found above the initial point. No? This is the initial point, and this is the final point. So the final point is found above the initial. So that's positive y. And this 50 meters here represents the x. So therefore, we're going to use the formula that y is equal to x tangent of the theta, which is the angle of inclination, minus the gravitational acceleration, x squared, over 2 times the square of the initial velocity, cosine of square of the theta. No? So given ang atong theta, given na sad ang atong x and y, then we're gonna proceed in solving for the initial velocity. So we can have y as positive 35, then x as 50, tangent of 45, minus this is 9.81 times 50 square divided by 2 times the square of the initial velocity, cosine of the square of the 45-degree angle. Okay, so we're gonna find that value of the initial velocity. So you have 35 equal to 50 tangent of 45 minus 9.81, no, this one, 9.81 times 50 square divided by 2 times the square of the given, the unknown, times cosine of 45 square, and the value is There are two values. X is oh no, not x, but VO rather. So the velocity is 40.351 meter per second. Something like that. Okay. So ingona na if that is what you wish to have, diba? So kung gusto kag ingona na imong answer. And then we can actually use the other formulas if you want to, no? So like na kay final velocity equal to the initial velocity, then plus or minus acceleration times time, then you have final velocity square equal to the initial velocity square, plus minus the twice of the acceleration times the distance, and then the distance equal to initial velocity square, no, initial velocity times time, then plus minus 1/2 of the acceleration times time square. So it's really all up to you kung gusto ka mo gamit ani or just use this one, no? So anyway, you can actually just derive the same answer using this one. I need not to solve it anymore using this one, as I have already proven from the previous examples nga pwede ta makagamit any examples as long as we know how to um, manipulate the equations or formulas given. Okay?